Okay, okily dokily. Well, yesterday we created a swap chain, and today we're simply gonna follow through with hopefully creating a graphics pipeline. Well, we will see how far we go. Then let me switch to this here, and yeah, there we go. So do we still need that? I doubt it. Yeah. Here's our swap chain. And now we create the pipeline, I hope. So Jesus. Not like that. And for the moment, we pass our context and we will see. Oh, maybe. And begin. All right. Well, never mind. Loudspeaker in the way. So is it still okay? Yeah, I hope so. Yeah, I think we all know who these guys are. That's what we want at some point. Alrighty. Compiling the shaders. Loading a shader. Creating shader modules. Alright, let me go one back. Oh no, okay, that's okay. This is where we left off last time. So okay, then let's have a shader. For vertex colors. think we can do that. So should we make a folder for that? I think we should. So touch. What do I want us? Oh, okay. Shader vert and shader frag. So GL positions. So fragment shader per vertex colors. Okay. As always, we're stealing. And then we have also a bit of a fragment shader here. We just follow along. For vertex colors, okay. Grab them as well, but that would be in the vertex shader again. Maybe we can. Hello? So, and we add this into our fragment shader. And then we do this. Okay. So, compiling shaders. So we are in source, but shaders. I think we should rebuild shaders. So this can be removed. We need the script path. Build their name. That's. Shall we do this? Oh. Let's. This is all not correct. This needs to go. For the moment, doesn't make any sense. Insert shaders. Shaders. GitHub 3 shader. Good. That's nice. Yeah, we can definitely call it, so we don't really. So, subprocess run. All right. Okay. Oh no. Does this work? Yeah. So my guess is that this goes like that. Shaders vert. Shaders vert. Okay. And in this case, was it SPC? SPV? Spear V. So, alrighty, so we have a shader. not gonna do this. Not by a long shot. So where is the base? Yeah, exactly. Okay, from now on. Okay, so do we have boolean? Oh yeah, we have booleans in here, so we can load file. Alrighty. So we need some file. I did this wrong. So if check SDL. I'm not sure whether this is a good idea, but we're gonna try it nonetheless. So the assignment. Const. All right, I think we can. Of course, the file size should always be greater than 0. But ah. Okay, memory void comma. So just say we have the memory. Now we do read IO stream. SDL close. Alrighty, I don't have a free memory. this void. We add logging and other stuff to this later. So if there's something wrong, we're closing it. Even though that should be obvious. Out memory ist gleich P and out size is N. Now theoretically, closing can fail as well. So, or can it? Yeah. This returns no 0 on success. Okay. If just so that we have that on record. So I think we should, no, we're doing it like this, SDL, and same. Yeah. So there was no memory. Here again. Fail. I doubt that it will ever fail that way, but and of course in this case we also have to I think we can free the memory first, I think. Yeah. And the same here. Check SDL. I know this is a little too complicated for such a simple function, but technically these errors can happen, and we want to be at least aware of them. So other than that, we give it back. And we have this, so okay. Can we load a shader? Can I boolify this? So back to the graphics pipeline. So we have so bird shader. Count is maybe the wrong word. Just so. All right. Can we do this? I think for the time being we do this. Well, we're currently just beginning to create the graphics pipeline. So there's still a lot of code that that needs to happen. But just yesterday we created the swap chain images, but now we're waiting through here. So, but right now here at this point, so we're not even halfway there, I would say. So, oh, and this is also wrong. What am I doing here? It's not even there. I mean, it's 4 or 5 more chapters before one is actually going to see the triangle. But I mean, it. Yeah. Well, yeah, sure, but it will happen. Yeah, I ran actually through it offline a couple times, so this is why I'm being very, very verbose with it here on stream. But so I have done it a couple times, and but I actually made a huge mistake. Probably more. Yeah. Oh, that's yeah. Yeah, sure, but it's not just the tutorial. I also, as you can see, I take the liberty whenever I encounter a Vulkan structure or some bit fields or flags or whatever, I put them in comment in code. As you can see, this so this doesn't technically count as code. And I also I want to debug and want to have all that information. So as you can see, whenever I encounter a new structure, I dump it. right? So, and as you can see, there's a lot of a lot of stuff in here, right? So this technically doesn't count, right? But yeah, the actual code is a lot smaller, but I just yeah. But as you can see, I mean, there's lots and lots of things, and I think I don't know, the largest thing was probably the formats. I'm not sure. There's hundreds of. Oh yeah, just look at the format structure. It's I don't know, 200 lines or so, and then again, and yeah. But that is then what allows me to, do stuff like have it in a log file, right? Where I can really, I see every extension. I see what, all the device capabilities, what is supported and what isn't. So I have them then neatly in the log file. I mean, obviously, at some point we're going to turn it off. We don't need all that information, but since this is sort of multi-platform, although I haven't compiled it on the Raspberry Pi and on Windows for quite some time, it's, you just immediately want to know what, where things went wrong. And so you have to dump everything, and that dramatically increases the lines of code, but it's more or less easy code, I would say. It's just that, oh, okay, you just log something, right? It's not that truly difficult. So but yeah, we're wading through it. Bird shader memory size. And yeah. So yeah. And now we have to check the damn thing. No. So, oh, and we're going to have vert, no, shader dot vert dot SPV, I believe. And frag. If so, I'm gonna steal this. Okay, do this. Let's see whether we can. Okay. I didn't press escape. Something ended on its own. I probably made a mistake. So I probably screwed something up. Oh, failed. SDL. Okay. Could not open. Ah, because. Yeah, this is tricky. I probably have to now walk into the directory. Yeah. So, but now, okay, maybe. Okay. Yeah, at some point I need to add some functionality to yeah, to sort of find files, and but right now all paths are hard coded, which is of course bad. But so, but for the time being, we could log. Oh, so and maybe for the time being we can just remove this. Ah, here we have. Well, that seems reasonable. Hello and good afternoon, Eternal Divine Fox. So, alrighty. Where are we now? So, we loaded 2 shaders, but now we need to kind of. I'm doing fine, thank you. And you? Oh, we need a shader module. Alright. We need a shader module. Static. Oh, well. You have a task cut out for you. Well, neural network, that sounds way too complicated. I wouldn't wanna. I don't envy you. That's just. And SQL. Let's so. Should we really? We will see whether we need that. So. Okay. Let's not pass the fucking context. That's stupid. So, void. I believe const. Java. Shader. Code. Shader code size. And I think we want to have some form of output shader module, VK shader. Oh, go away. Out shader module. Just don't do that. So, so what does he want me to do here? Oh, okay. Some create info. What scale? Well, yeah, that still sounds awfully complicated. I mean, with the whole, you know, machine learning and whatnot. I only briefly read into this and just, rather not. It sounds complicated. It's just, but yeah, it's definitely interesting to, if you can command this stuff and you kind of, if you really know what you're doing in that field, I think that's that can be a benefit. Mm-hmm. So, VK shader module, create info. It's not too bad. Yeah, especially if you can, more coffee is good. Yeah. What am I doing here? Hey, you. Oh, just I will I mean, technically it doesn't matter because I rewrite the structure every time with every member, but theoretically you only need it once, right? So if Vulkan is perfectly fine with this being local pointers, so if you do it static, you kind of save the pushing this stuff on the stack once. It's just silly, it doesn't really one could completely unstatic it, and then every time you call create shader module, it would sort of renew the structure, but when it's static, of course, it only does it once. But since I'm touching every member, it's not, it would be helpful in a way if you would only change 2 or 3 members, right? If the rest is static, you don't technically reinitialize them every call, but oops, yeah, but it's more like a habit. It's not really, it's just. No, of course it's not. Yeah, absolutely. But technically, even if it costs almost nothing, if it doesn't really need to be there, right? You know. Yeah, yeah, of course. In the general scheme of things, this is not, you know, if this will never be the bottleneck in any serious whether you do it. No, no. Yeah, sure. That no, no, but of course, if you're really serious, then yeah, you want to have some form of pipeline cache or something where, yeah, absolutely. But for the moment, we're mostly sort of toying around with it, and we just, you know, don't really interact with it all too seriously. We just want to more or less play around and see what happens, right? So, but the moment you really want to engage in really having a project big enough that it would require a pipeline cache, it's just that's still a long way to go. Uh, hmm. And of course, we're casting this unit. And maybe, just so the paranoia, acquire. And is that correct? Just I think this this and this and this. So yeah, that should be okay. Yeah, yeah. No, I think, I mean, as you can see here, it is technically a uint32 pointer. So it would also require a cast in C. Um, so, but we want to make sure because I think it's a 4 bytecode thing. And yeah, so we want to at least, I mean, I doubt that malloc gives you any, probably the malloc will align things either 4 or 8 bytes anyway, so I don't think that there's anything to worry. You can probably immediately cast this. Yeah, but the address you receive will very likely be, I would say on a 64-bit system, it's probably 8-byte aligned. Probably. I have yet to encounter something where it wouldn't be. That I don't know. It could even, but I'm not sure whether they always are. I'm not. And obviously I'm not sure what the alignment currently is, but yeah, you can also influence it. That is very likely possible. I mean, it's also advantageous for SSI, SIMD. SSE is old. No. Yeah, is there even yeah, there is some things that are there. That's just oh, and then we have this guy here. KC shader module. We need a device. Alrighty. VK device. Not that we need it, but we const it anyway. So, device. Oh yeah. Shader module create info. No allocator. But out. Hey. Out shader module? Why not? Mod. Oh Jesus. Can you type? So out shader mod. And of course we need to check this. If so, but let me check. VK result. Oh yeah, success. That's what we wanted to know. Now, is it even a timed block? No, it isn't. So okay. Doesn't matter at all, but and maybe we can also acquire this. So we need the device and the code, and now we have this guy running. Look. Oh, it's only this, so third shader. Hey, this fucking IntelliSense. Why does it? I'm pretty sure it's like that. And then we had BC device. Yeah, idiot. Vert shader resize. Am I not passing the Vulkan context static? Oh, okay. So if check compile this as well. Vert shader. And another one. Will it compile? It won't. Why not? Oh, okay. Idiotsky. Right. Nice. We're getting called out by the validator. Okay, create shader module worked. And this is the shader memory. Where is the... Ah, yeah, there. Okay, we have some weird address. That looks good. And so, okay, so apparently we have a shader. A shader module, I should say. Okay. The cleaner, should we? All right. Device. Okay. VC. Vert shader. And my guess is this is null. Not that it's necessary, but... Okay, the validator is happy again. And for a brief moment, we created a... Okay. To actually use the shader... Okay. Pipelines, data stage, create info. Let's get this guy going. Oopsie. Let's leave a little room here. So, pipeline, shader, stage, create info. So, pipeline, shader, stage, create info. So, alrighty. Pipeline, okay, that is goes without saying. Okay. Stage, where is, oh, as it so happens, we're right there. Vertex bit. Oh, we need 2 of those. Wait a minute. Module. Vert shader. That will be the illustrious main, I believe. Yeah. Pipeline. Okay. Oh, yeah. Well, you mean like kind of professionally, yeah. I think it started in, I want to say 1986 with a Commodore Amiga. And briefly before that on a Commodore 64. But professionally... yeah. It happens. Yeah, although in recent times I haven't done any kind of assembly stuff at all. It's just assembler is no longer fun. Well, it is fun if you're doing the right things, but it's too tricky, especially cross-platform. With it's just yeah. Shouldn't we? Okay, so we need to... Oh, well, it's a... Well, I mean, if you can utilize sort of NASM or anything, okay, then you maybe a little bit. But if you really want to hardcore optimize something, then I mean, you have to, it goes in several directions where it gets bad, right? If you need to deal with kind of thread pinning and really probing the CPU, what you can actually do, and yeah, it can get tricky, and it's not. I don't know. And so I'm happy that a lot of the stuff the C compiler does, and you don't really need to care about it any longer. And so, but this, let's just call this vertex kind of thingy. Okay. Okay. All right. I heard you. This is that. And that will be fragment. And that is frag shader. And of course, yeah, that's pretty much you're asking to get a lot of work. Yeah. And yeah, I mean, obviously, it thoroughly depends on what you're doing. Sort of in a game-like environment, when you try to sort of with SIMD instructions make some of your code run fast and parallel and whatnot, then yeah, that can be sort of fun to a degree, but at some point, if you think something more general, if you make some form of equation solver and that has to run on God knows how many platforms and fully parallelized with lots and lots of different threads and whatnot. And then of course you have things like what if you detect the CPU and certain features, but they're sort of disabled by a kernel, right? It's like C groups under Linux, right? And you have to sort of, yeah, really, if you really want to get every last bit of performance out of something, it's a lot of effort. It's just, and then you do this for the next platform again and again and again. Just, I mean, it depends, yeah. Yeah, absolutely. But at some point, right, you algorithmically you're in the clear that then it's okay, right? You realize, okay, this is sort of the best algorithm that you could possibly choose. And then of course then it's more or less pleasing the hardware, right? We say, well, how can I get these ducks in a row that we can eat them in parallel and just make it as fast as possible? So memory is just cache for getting it somehow quicker into second, first level caches, and then of course eaten by the CPU, and also transfer maybe to GPU if that's also, but there's Yeah, but it becomes, at a certain point, just the biggest improvement obviously comes from algorithmic improvement, which is okay, can use a completely different approach. And yeah, but at some point, if you want to go beyond that, then is when you're really fighting. And yeah, yeah, sure, exactly. Of course, that's you have then a piece of code that is an orgy of if defs, if you want. And yeah, and at some point, is yeah, it's yeah, but one one doesn't, as I mean, it is so. I mean, most of the time, right? You don't even need that really hard. There's very rare circumstances where you need that. I think, for instance, the guys that created the Intel math kernel libraries, right? They although they kind of obviously only work on Intel CPUs, but I believe that their matrix multiplication, that's also for larger dense matrices. I think it's probably fairly performant, and of course, you can almost presume that everything that can be done here to make it fast is being done, right? So, I mean, it's the CPU vendor that makes this, right? So, oh yeah, I mean, don't get me wrong. If you nothing assembler, but my opinion, strictly so my opinion, assembler is way fun when you have a Commodore 64 and you just where it it kind of gets there. I think it's really fun. It's not all that challenging in a way. It's fairly, you can in an afternoon you can familiarize yourself with all the mnemonics and what they do, and then you can immediately sort of hard code, and it's just that's fun, right? But and you don't have to take the environment or anything into account, right? You just use any kind of, yeah. VC20, Commodore VC20 would be even simpler, I would say. Yeah, but in a modern CPU, I mean, unless you want to really go right after the boot stage where if you want to make an operating system, right, then but this also becomes tedious. It just, it's difficult. Yeah. Yeah, but just hacking assembler for assembler fun's sake, that's, yeah, I think Commodore 64 and Amiga, stuff like, oh, and even early PC. I mean, yeah. Yeah, that's that exactly. But or maybe if you have old hardware laying around, or maybe DOSBox can do something where you could, but even I don't know whether in DOSBox you can switch to protected mode or stuff like this. But it's not really, you're not technically working with a machine any longer. You're working with an emulator, right? It's just so. So, but now having a really old machine there and just hacking at it for fun, that's great. Yeah. Now I'm thinking why I haven't done this directly in the. Let me. Yeah, that's that's quite difficult. I mean, that's just. I mean, if you 16-bit, I mean, that's just if you have segmented memory and Yeah, no, and now and I mean, I think this is kind of the sad part is also the CPU even nowadays doesn't give you its full instruction set, right? You're still looking at an x86 front end of this. I mean, it's okay and probably, but it would really be interesting to have a fully featured, to have a CPU that where essentially has no backward compatibility to anything, but it's just a RISC 64-bit CPU, and you do sort of everything yourself. That would still be interesting. So it doesn't need to compile or sort of, yeah, that would be nice. but it's but it's just life is on life is too short. It's just, it would be fun for a week, but at that point it's just, yeah, but I mean the sad part, or the well, thankfully, one might say, since I mean I guess the average Intel CPU core, they have so many cores and also proto cores inside of that that they can easily have an x86 front end and then assemble that into whatever the actual underlying thing is. And it since it's pipelined anyway, the worst performance impact may be an instruction or so. And given that you can instruct also, do this all in parallel, I yeah, unless you're really strapped for die space on the chip and you really need to get rid of all this stuff and sort of reutilize this as something else, I'm not sure that and then it probably wouldn't be worth. I mean, it's not like this would be blazing times God knows how much faster, right? I mean, so then in that case, might as well stick with x86 or whatever we get. So I think pipeline shader stage. I think we should have done this. That's way better. And then we don't need this other stuff. So no, no, no. It's just I'm dabbling, as they say. It's nothing. Yeah, it's nothing serious. I just no worries there. That's fine. No, I'm a programmer, right? I mean, people on occasion people pay me to to nah, yeah, I work with a company for a long time, and yeah, so there's no, I'm only sort of I'm interested in hardware and whatnot, but it's on some point, there just isn't enough time, right? Although when I was in school, we there was a lot of sort of, let's just say, electronics and things about, but it I mean, if you go through the whole electronics route and really dealing with hardware and doing it, like actually making hardware, that's very while interesting, it's just, I think you can only do once in a life, right? Either you do software or you do hardware. If you do both, um, some people probably can do this, but it's, you know, but yeah, dealing with electronics and doing sort of simple even stuff like Raspberry Pi stuff. It's, I mean, but Raspberry Pi, I mean, that's no longer simple electronics, right? It's you can make your own flip flop, but that isn't helpful. I mean, I think there's this guy on YouTube, and it's Ben Eder, I think, and he built a sort of a Hello World computer. That's that's really great. I like, and he also built his own graphics card. All right, it's just really out of very simple, still integrated circuitry and whatnot, and digital technology, obviously, but still, I mean, it's quite effort, and it looks very interesting. Yeah, yeah, if you can do that, yeah, I always, when I look at the Verilog files in the Mister project, right? This where you more or less simulate the hardware, emulate the hardware, simulate whatever you want to call. I don't know what's the correct term is there, but you have an FPGA, and you pretend to be the hardware, and you just redo the hardware in Verilog. That's, I mean, that's really nifty and really cool, but it's just, yeah. uh, but as I said, doing this doing this professionally, however, I think you need a lot more skill. Yeah, yeah, but hardware has a, it, it's it's interesting to entertain and to play around with, but at some point it gets serious, and software, I think, is a little easier. Also, yeah, the, with hard, I wouldn't even know, right? How do you if you think about modern chip design or so, right? How do they make this smaller and faster? I mean, almost at the nanometer scale, there's very little you can do. Everything you do has, these, I don't know, you need to sort of lock up 100 physicists in a room to even do some minor improvement somewhere, right? It's just, and these people have all, big brains, and oh no, I'm consuming whatever they produce. That's easier. You don't want to, yeah. So, yeah. But the synchronicity, of course, ends when you get, if you have 128, 256 cores that run in parallel, right? On some level, there is a synchronicity. They're obviously timed, or almost timed, by the same clock, but yeah, yeah. Well, yeah, analog. I don't know. Is analog logic even a thing? No. I know that people used to build integrators and different and stuff like this way back in the day, when you had these wonderful old sort of oh, geez, what's it? Oscilloscopes, right? The analog ones, and it, people did a lot of analog logic, but yeah, yeah, yeah. But as you can imagine, right? The amount of knowledge that is required. I mean, this is it's far removed now from what, let's just say, Steve Jobs and Steve Wozniak was doing, right? You cannot in your own garage make an improvement on CPU technology. It's just it's virtually impossible. I would say. Maybe I don't know. Maybe there is. And there are people on YouTube that built their own transistors and whatnot. But let's face it, that's not, the revolution in this term has already been done, and now it's really hard work, and you need the really big brain fellows to improve on that. It's just, yeah. Might be put on. Yeah. They put on the correct. Yeah. To avoid. I mean, well, future will definitely be interesting. That can be said. So, so we have shader stages. Okay. Oh, alrighty. Just take this. Oh no, this is just a pointer, I guess. So, these are these are just handles, right? Oh, okay. I guess I have to do that, but I don't want to. Oh God. Oh no. Oh no. Oh, this will make it even more ugly. Okay. I'm not printing these flags. Yeah, exactly. Yeah. Yeah. And of course, we're gonna do this static dynamic states. Port. Hey, oh, where am I? Ah, Jesus. I only wanted this to be here and here. This is a viewport. So we get this guy and oh no, Dynamic state create pipeline. Dynamic. Oh, okay. That sounds... I'm not looking up these flags. So, pipeline, dynamic, state, create info. All right. Dynamic CIM type. We want to do this. Oh, we don't need that. Right, there you go. So, dynamic state. Ay. Vertex input. That sounds reasonable. So, pipeline vertex input state create info. Oh, hey. Okay, right now we have vertex binding count 0, binding descriptors null, null, and null. That's interesting. So input assembly. Okay. So pipeline input assembly state create info. Okay, a triangle list. There we go. VK false. Okay. Only 200 more to go. So viewport. So surprise, surprise. So we should have the swap chain extend width at our disposal. And the height. Oh, okay. I see it on your way. What? Viewport and Mr. Scissor. All right. For completeness sake. I'm sorry, but we have to do this as well. Mhm. set x y scissor. Oh, why doesn't this is so horrible. Extend width. All right, so we have this. So we need to enable respective. Oh, okay. And then you only need to specify their count at the pipeline at create time. But this we have already done, haven't we? Ah, no, no, dynamic state. That is the very thing. Yeah, this is the guy. So we have done this. State view, okay. That will be new. Okay. Create here. Catching. KC. Pipeline viewport state create info. Viewport count as 1. Scissor. Shouldn't I be using the scissor thing that we... Wait a minute. Okay, the actual viewport. Then, okay. Viewport without the without the dynamic state, we would put it in there, but we don't. Okay. Whatever. Hooray, Mr. Rasterizer. me see. Pipeline, rasterizer, state create. Right. Formals. Polygon. I should. I don't know. That's bad. So. Depth clamp enable. Discard enable. Yeah, polygon mode. Do we even want to cull? I don't think so. Cull mode. But we will fix this later. I don't think we want that. That is what we want. Okay. Depth bias enable. Formats. Constant factor. Okay, 0, 0. Depth bias clamp is 0. Slope is 0. And line width was 1. Yeah. So we have a rasterizer thingy here. Oh, no multi-sampling, please. Mm. Pipeline multi-sample state created. CI. Obviously this. Sample shading enable is false. Min sample shading 1.0. Sample mask null. Okay. Alpha to coverable. So false and alpha false as well. Okay. Oh God. When will it end? So when will it end? Samples. Okay. So color blend attachments. Pipeline color blend attachment state. Exactly. Whatever you say. No. blend enable false. Color blend factor. Source. Color blend factor. Dest color blend factor. Color blend up. Alpha source alpha blend factor. 1. Alpha blend up is add. Okay. So blend color blend. And now comes the create info for this. Okay. Pipeline color blend state create info. Hooray. So No logic up. Good. Logic up copy. Attachment count, that should be 1. Okay. And that will be this dude. Okay, blend constants are all 0. Alright. Oh, we get a member. Isn't that cute? Pipeline layout. Peoplina. So. We have this guy here. Wait. Aren't we missing something? Pipeline color blend? Ah, okay, we're missing this guy here. No, but we... Ah! Well, that was interesting. Create info. That's what we wanted. Oh, this makes perfect sense. Pipeline layout create info. Well, yeah. You too. Have a nice day or nice evening. I don't know. Good. So. So, structure, pipeline, create. Set layout. Set layout 0, 0. Okay. 0. Push constants. That looks like null. Oh. So we already copied the create. Pipeline layout, create info. No allocator. Pipeline layout. Good. Check Vulkan. Block. So it should be destroyed at the end. Okay. But we haven't even created anything yet. Okay. If I don't think that I need that, but for completeness sake, let's do this as well. There's probably no surprises there. PC device. So how? Okay. A lot of stuff, definitely. All right. We still have a shader module. Pipeline. Create graphics pipeline. Yeah, here was 0. That is good. So next. Yeah. Oh. Renderpass. Oh. Alrighty. All right. Okay. Key attachment description. Attachment description. Okay. Okay. Swap chain surface. Okay, flag. What are the flags? All right. So flags. Samples. Store operation. Don't care exactly. Image layout undefined. Yeah. Attachment reference. Attachment, no. Layout is this. Subpass description. Wait a minute. Didn't I make these static? Oh, okay. So SD subpass description. Oh, we're running out of letters here. Bind point graphics. So I presume this to be 0. Bind color attachment. Okay. Okay, that must be AD. That must be null. Oh, that's color attachment reference. Ooh, we made it wrong. That is AR. So So I presume these are all null because he doesn't set them explicitly. Render pass. Hmm. Render path create info. So render path create info. What did do? See render path. Oh, hi ho. Render pass create info. Oh, zzz. So attachment count is 1, and the attachment is AD. So pass count 1. And that would be SD dependency count. I presume these to be 0. So we need this. Oh. Yeah. I think, right? P dependencies. I think this is. Here. Resolve attachments, these are all. Okay. Ah, the compiler will say something. Let's just see. Wait a minute. 4, 8. Okay, that 2, 3. Ah, yeah, okay, I'm sorry. Ah, okay, yeah, thanks. I thought, okay, it's P, and I hate technically this, this leaning towards the Windows sort of Hungarian notation thing. And I just saw the P and I saw, okay, it's a pointer, but obviously, yeah, you're right. Yeah, that's that's not good. Yeah, thanks a lot. So create render paths. Give it. Oh, this isn't complete. There was something missing. Render path, create info. Oh, allocator. We don't have one. Say render path. If so and paranoia. Render path. So pipeline layout and then the render path. So the order layout render path. Layout render path. Okay. Conclusion. Well, before we conclude, we're gonna check if this works. Well, we haven't called it anywhere, so there's no point in. Yeah, but it compiles. So graphics pipeline create info. Now we're cooking. Yeah, idiot. What are you doing? So. Graphics pipeline create info. So. So, graphics, create info. This will surely be there. That will be null. Stage count. 2. Oh yeah, 2 shader stages. Stage count. Shouldn't this be a size of? Okay, shader stages. We have them here somewhere. Dynamic states. There. These guys. So. Vertex input stage. Okay, these are all these guys, so. Oh, I gotta put a bookmark in there. Crazy. Tessellation? That better be 0 here. It's not mentioned. So viewport state. Okay, we have this guy. Viewport. Multi-sample. Okay. Yeah, I thought I Well, we will see. Just I do K and J, but yeah, but it only oops. But it only goes there. Can I do? Ah. That's a wait. Depth stencil? I don't think I have that. No, of course not. So that would be null. I have the color blend thing that I have. Oh, we're almost at an end anyway, so it's just so dynamic state that we also have. And the pass. Subpass. Subpass is 0. And base pipeline, that looks like 0. Good. 0. Index, probably 0 as well. Oh. Oh, no. Nobody saw that. So, okay. And we have a pipeline. Almost. Okay. Device. I think pipeline cache. We currently don't have one. Oh, it's VK null handle. Oh, dude. Alrighty. One pipeline info. Okay. One fixed pipeline tree. Fixed pipeline create info. Okay, allocator is 0. VC graphics pipeline if check. Okay. Walled up graphics pipeline. Good. Okay. Okay, then we destroy the damn thing. Very nice. But I believe I haven't actually called the create render pass anywhere. So we'll see. Yeah. I must have somehow missed that. Or is it coming? Okay. So we do. Okay. Surface, fill, blow. There we go. Not good. No. Correct. So, but or maybe create render pass. Looks right. And then we have create graphics pipeline. Good. And running. Ay. Stencil load up. Previous. This is color attachment. Store up. Oh, okay. Thank you, Mr. Compiler. So. Set but not used. We don't care about that at the moment. Okay. check if it works a little. Create pipeline layout. Pipelines, that looked successful. Okay. So we did get a pipeline and good. That is sweet. So we destroyed it as well. So we have a pipeline. Now we need frame buffers. Oh, frame buffers. So. Wait a minute, but aren't these frame buffers? A frame buffer? But how many? Oh yeah, that's what I wanted to know. These are exactly the amounts that the swap. I mean, makes perfect sense that way. So. Should we? Oh, we will see. Oh, okay, I need to make the function. Okay. Ah, okay, we can do this and then okay. Yeah. Frame buffers. So. Yeah. Okay. Attachments. So this is only one. Why not? Why do it like this? That's really strange. Shouldn't this be swap chain views? I understand, but why are you doing it like this? Is there a reason for this? I should be able to do this. Well, we'll see. Let's not question that directly. So frame buffer create info. So attachment count is 1. Okay, so create frame buffer, create frame buffer. Yeah, this was the swap chain. Okay, that was correct. Can get rid of all this. Device frame buffer create info. No allocators. me see. Frame buffers. I shouldn't have removed it quite so quickly. Yeah, that seems correct. Okay, if check ding ding. Bam. Oh yeah. Why would? So this is a pointer to an image view. Why can't I? Why do I need this? Why can't I do? Oh, wait. Attachment? No, it's pick image view. Why can't I do this instead? Why the local cop? I don't. Okay. Won't question it for now, but. Okay, we take care for the destruction later. If okay. Before the image views and the render path. Okay. Before. We should delete it before the image views. Good. Destroy device. What's it saying? Before the image views and render pass, that it may be based. So we have to probably put it even here, I would say. Frame buffer. Oops. Rethinking that. And this. Alrighty. Wait, what? But this compile? Compatible. Ah, okay. It's already an array. Right? No? Oh, okay. Destroy frame buffer. So. Did you mean? Ah, Jesus. Right. Create graphics pipeline. Create frame buffers. That seemed to look like it worked. Yeah. Okay. So we have peak Pharaoh. Oh god. No. La la la. A command pool. I guess it's kind of this. Static or create command. Well, okay, we need the need to call it as well. So we have these things already, so we need that guy. So we have all the Q family indices we could ever want. So common pool create info. So, wait, that's totally wrong. So S type. So what kind of Q? Okay, so you want the graphics Q family. Okay. No problem. We have that thing. There you go. So, pool. Device. Common pool create info. No allocator. See common pool. It. If check Vulkan. Okay. That was it? Oh, okay, we need to delete it as well. Okay. Alrighty. Oh, do we compile? No fuck-ups. So we have frame buffers. Command pool seems to be happy. Good. One more. Oh, a command buffer. Yes, sir. So. Alrighty, let's do this and that. Command buffer allocator info. And alrighty. Let's see. Cool. Level. Oh, this guy. I suppose one. Yeah. Oh, we're doing allocations. That's nice. Device. Buffer allocation info. Um, command buffer. If check So we have this guy now. This. What's this? What are we? Oh, okay. We record. Buffer. Okay. I don't trust this guy, so record command buffer. Get this camel case out of the way. Image index. Sorry. Yeah. Nice try. So okay. Begin buffer. Ching. Command buffer begin info. I did it wrong again. Was ich flags? Probably not as well. It's all null. Okay. And we need this guy. What is it doing? So this may be null. CBBI, I believe. Oh, check. Vulkan. Dingo. Dingo. And time. Okay. Okay. Starting a render pass. Begin render pass. Begin. Oh. Ooh. That's quite the monster. Render pass begin info. So render pass. Okay, it used. Yeah. I was so hopeful. Why passing this stuff? Well, okay, never mind. So. Yeah, let's pass it. My guess is it's the image index, exactly. Ka-ching. Require. Render arena. Oh. Arena? Area. Okay. Offset. Extend. Okay. Render area. So this is either or, I believe. Right, this is some... This is a union, if I'm not mistaken. Yeah. Depth. Stencil family. So, submit and okay. Where do we? Oh, strange. Okay. So if we only have this one. Yeah, I know. I want to prepare this thing for when we have a if we also have a depth buffer. Well, right now we don't have one, so So the clear value is 0. Float 32. So 0, 1, 1, we can keep that. And the 1. Depth, stencil, depth. Depth, stencil, stencil is 0. So, and I think now I can pass this one here. But that comes later. For now, we only want one of those. So let's do a render. That is fairly common in Vulkan, that you pass stack variables. I mean, I also wondered about this, but that's, you can see it's also in the original, right? It's here, you see the clear value, and it's being put into the structure. It's this is also in part why I sort of proactively make it static as well. Because I'm not so sure if this is a good idea, but it seems to be. Seems to be okay. So we will see. Command buffer. Render path begin info. What the hell is the subpass thingy? Ah. Inline, good. Ah, that sadly doesn't fit anymore. So if, oh wait, is this void or is this, I have to, no, it's void. Okay. Cha. If it's void, then it fits. Okay, binding pipeline. Why am I always moving this. So command buffer. Oh, this guy wants the graphics pipeline. Well, you can have that thing. Hey. Graphics pipeline. There we go. But we have to be that guy. So oh god, the whole viewport stuff again. Oh no. Alright. Wait, in the viewport structure, these are floats? Yeah, apparently. Okay. So we get the scissor. Okay. Whoop. And we steal the scissor here as well. Ka-ching. So but we're still gonna copy the prototype here. Ching, ching. Hooray! We're drawing a triangle. Who would have thought? Command buffer. Okay. And render BK common buffer test. Jesus. Oh wow, yeah. Okay. I'm sorry, but it has to be done. There's just no way around that. And that pass. And now BK end common buffer, which is gonna be similarly silly. So but we have a return value this time. If so record, we have not called this anywhere. Check record. Did I? Oh. Ah, okay, we don't need to. Oh, okay, yeah, I see it all your way. That's not where this goes. And next. Oh, hobbla hobbla. Oh yeah. So we really want to do that? Okay. Drawing a frame. Yes. We have a rough idea how this works. So. Create sync objects. Okay. That sounds a lot better. So check create sync objects. Scrolling. Static. So get this guy. Some inflate fence. This create single object. Oh, of course. Semaphore info. We need to get rid of a few of these. Okay, this thing apparently is very simplistic, so semaphore create info. That is probably null and probably null. EK fence create info. Fence create. Okay. If we do this, create semaphore. No, that guy. So, yeah. Create semaphore. Catching. Device. Semaphore create info. Null. Oh yeah. BC. What What was that? Images available semaphore. Oh. Oh, and there's a result. So we have to check. If check Vulkan. Block. Oh yeah, first we have to check VK result. Okay, success. Good. No other business being returned. That's good. We gotta repeat this for the other guy. That is the render finished semaphore. And we also wanna paranoia. More paranoia. And my guess is now we create the fence exactly. Device. Fence create info. No allocator. And EC in-flight fence. Good. If check Vulkan. Does not compute. So we have a fence. Okay. Now we need to destroy them as well. So only need this once. So render finished, server 4, render finished, render finished. Let's see. Flight. And my guess is that we're destroying a fence. Yeah, I was wondering that as well. And shouldn't these things be pretty much be deleted very much at the end? But I think later in the tutorial, before you clean up, you wait for the GPU to finish everything anyway, and then you destroy everything. That will come up later in the tutorial. So, so I think for the moment, I think the order might not be that important, but we will check. Oops. So VC device in-flight fence and null. So now we have this guy, and we can clean up. Okay, there's a lot of draw frame stuff here. But let's quickly check in his code how the cleanup works. So clean up. He, at least as far as this example went, it seems to be destroying these things first, yeah. So only 400 more kilometers, and then maybe, just maybe, we get to see a triangle. Or not. Waiting for the previous frame. So command pool. This was destroy. Did we created them, yeah. Just see if it compiles. No, everything we do wrong. So buffer. Oh, that's an interesting thing. Okay. Okay. Nothing bad seemed to have happened. These things all look nice. Okay. Then, oh, we need a draw frame. Oh, yeah. Boy, we've been waiting for this. Draw frame. Yeah, we're not even there yet. And that is a fake cheating triangle. That is a triangle defined entirely in the vertex shader. So it's, oh yeah. So draw frame, waiting for fences. So and of course, new function. I have to check. Oh my god. Da, da. Okay. Alrighty. Oh yeah, we wanna check what is. Okay, timeout. We will never have timeout because the timeout value is larger than there's atoms in the universe. So okay, that's great. See device. PC in-flight fence. Fence count. Fence. Wait all and timeout. Yeah, okay. But can't do it. So check. Vulkan. Ka-ching, ka-ching. So after we waited, alrighty, reset fence. Can do. And also here, it's probably timeout. No, it's only success. Okay. Oh yeah, it's a, okay. So PC device 1 and PC in-flight fence. If check Vulkan. Just so made it. Good. So bail out in case anything goes wrong. So yeah, that's what we need. Create sync objects. Wait, that was for the fence, right? Yeah. Create signaled bit. acquiring an image. Let's see what this guy does. Alrighty. Blockchain. Wall handle and image index. So what can go wrong here? Use it. Oh yeah. Okay, here we need to do some different checking. Can't just use our check function. But for the moment we don't care. Result. Acquire only. So but we will do this later. Reset command buffer. Okay, can only return success. That makes it easily checkable. Check Vulkan. Wonderful. Let me. So this will end time clock. False. Oh, we're drawing closer. Record. Command buffer. If check. Wait, does this? Ah, probably not. This is the image index. We okay. Submit info. Surprise. So submit info. Of course. Hey, double click the thing. So wait, sum of 4 count is 1. Yeah, that's what we thought. Wait, sum of 4s. Ah, this. Oh, okay. I see it all your way. It's one of those things again where I. Um. Image available. Um. Okay, what is pipeline stage flags? What voodoo is this? Oh, no. Oh, well. Okay. La la la. Yes. Yeah, I think so too, but I'll keep wondering, why does this guy make it that weird way? So I mean, it could be that these will become arrays later and like actual arrays, but so wait stages. Okay, that is then no wait stages, wait semaphores, death stage mask. Okay, this is here. Wait, so command buffer is 1. Signal. Oh god, yeah, another one. Okay, alright. I see it all your way. So, this poor guy here. Signal semaphore. Isn't the semaphore a signal to begin with? Oh, never mind. So. Test wait stage mask. Is there stage mask? Alright. How does it know how many are in there? So we have wait stages. Wait semaphores. Wait stages. Okay. Alright. We hear you. So. So you go into the queue, device, I believe 1, submit info, in-flight fence, maybe? Okay. VKQ submit can be VK success. If check. Okay. But let me briefly check whether this is correct. Submit info flight in-flight fence. Okay. Subpass dependency. All I want to have is a... never mind. When will it end? I don't know. Well, subpass dependency. Subpass dependency. Server. Source subpath. Okay. Dest subpath. 0. Stage mask. Source stage mask is this one. Destination stage is this one. Oh. Source access mask 0. Yeah. And dest access mask is this guy. Dependency flags. Dependency count is 1. And what? Dependency count 1. Dependency. But I don't. Wait. Ah, this gets into the rent. Okay. So, what am I searching? Dependency flags is probably 0 then. So. Where is our render pass info? Ah, okay, that doesn't even belong here. Go to the create render path. Da gehen wir jetzt hin. So, becoming render path. What? Here's the dependency. So my guess is we put this in here. Why is it whining? I'm complaining. Do we? Oh, we already subpassed this. Oh, okay. Oh. I hate it. So, dependency 1. SDE. So, presentation has 2 fields around. So, configure. Okay, present info. So, you cannot pass. So, got you no boy. You're gonna see the triangle soon. At least that's what I hope. So, present info. Hi. Hi. Hi it is. No. Oh, Jesus Christ, I don't know the semaphore shit. Wait, semaphore count, so signal semaphores. I would also say that this is an array count of signal semaphores. And then signal semaphores. Swap chain count, I hope it's only one. Swap chain count. Oh no. Okay, you could have multiple of these, I guess. Why this crazy notation? I really don't know. Image indices is 1. Okay. Image index. That is the image index, right? Exactly. Results null pointer. We're almost there. I can feel it. That will probably crash immediately. Hooray! Preset queue. Huzzah. So, oh, it has a result, and we need to check. Check. Success and suboptimal. Okay, this is yet another one of these things. VK result. Present. Okay. Maybe const. So, which queue do you want? The graphics queue, I suppose? And the present information. Can check. So, this yeah. We don't care. Oh, we need to draw it as well. Okay. So, but first we need to compile it. Well, struct counts from income. What have I done? Hey, go there. Oh, it. All right. No. Q submit. Oh. This one's the graphics queue. Doesn't want the device. Okay. Let's see if this is actually correct. Graphics queue. Yeah. Okay. Oh, weird. Okay, we haven't used draw frame. Isn't that a shame? La la la. Oh, we don't even. Ah, no, we don't. Should we? No. What we're doing here is draw. There, way better. So. No? But draw frame? Why no draw frame? Okay, well. If check frame. Draw Vulkan. Export it. Update. No, not. Wait, what? It's called update. Yep. And it's draw Vulkan. Okay, maybe if we are here already, then let's check the damn thing. Alright, alright. Here you go. Just in case. Alright. The moment of truth. Ta-da! A triangle appeared. And we get exactly the kind of thing that it said here. La 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 la. And but why was the screen red? I didn't want it to be red. There was a wait, some weird, mysterious wait call that I missed. Where is it? Oh yeah, wait divine. That's what we want. So if we have a device, although we should have checked this a little earlier, kindly just assume that we have one all the time. So, wait device idle. Yeah, okay. I would have never guessed that. Oh, and there is a result to it. Jesus. But we don't care for now. We don't care. Instead, gonna hunt down. No, what was it? Color. Oh god, how many scissors are here? Ah yeah, maybe here. No, this was the viewport. No, it has. Wait a minute, is it in raw frame? No, it can't be in raw frame. That has to be in the record here. Yeah, but I thought I took care of it. And obviously I haven't. That's so this should be some form of magenta and not red. But ah la 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 la. Oopsie. No. Ah, now the world is okay. Perfectly okay. Ah, triangles galore. So that's nice. So how much code is there? Oh, yeah. Okay, I'm cheating, but 6,000 lines, I think that... And it's not even a real triangle. So it's all fake. All in the vertex shader. Ah, yeah. And of course we haven't even recreated swap chains and other things. If I resize the window, we're probably being, yeah, we're getting pwned here. That's not that. Oops, I think we're done. Ay, 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 ay. Ay, ay, ay. I know this. I shouldn't have done this. No. Please let me kill it. Please let me kill it. Where are you? There. We need to do something about that. That's us, right? Bin bash. Shell integrate. Oh, we started it out of this dude. Okay. I hope OBS is still working. It looks like it. Yeah. Yeah, but now. So. I think I should have never started it out of Visual Studio Code in this shell. This is not good. Well, yeah, we definitely need to work on swap chain recreation and all that jazz. But oh, I think I'm calling it a day for now. After 5 hours and God knows how long we have a triangle. Let's just see. Maybe also not. Just rebuild I. Okay, and well, no problem. I'd be thankful watching. That's so, and just one more time, not resizing. Maybe since now we know that the color is correct, we can make it actually black as it's supposed to be. So, oh, I still don't know which one the alpha value would be. So, I presume this 3. We will see. That's definitely. And we have no full scene aliasing, but that's okay. And what does the log file look like? So okay, maybe we shouldn't really log every single frame. That could be a little excessive. Oh, what is this here? Error? Reset command buffer? Wait a minute. Command buffer must be allocated from a pool that... Okay. Okay. We haven't done this. But we still get a triangle. Okay, that's just it. That's something we need to check. Set command buffer. Did we overlook something in the recording of the command buffer? Or maybe we can check the code. Let's see. What does this guy do? Oh, he does this. And I'm pretty sure we don't. Or do we? We will see. Ah, we don't. So, create command. That's exactly what we want. Hey, just go back. La la la. Let's see. Now without errors, please. So, log file. Yeah, that's not working out. Graphics, sync objects. Now we can. Wait, do we? No, we're only recording. Okay, main loop create. Yeah. Okay. That's good. Alrighty. So, now without spooky error messages. Git status. Rebuild shaders. Git shaders. Add -u. Okay. All right. So what is the diff? But it's because okay. Yeah. No. Silly me. Should have done that before that. But good. I think we can do a git commit. The triangle is here. So, and where is my... Oh yeah. Copy. Git push. Right. And boom. So, well, thank you all for watching, and well, we continue next time. And yeah, but so far have fun, and I will call it a day now. So, and stop streaming. Click.